So my name is Paul Meighan. I'm a Director of Product Management in the Data Management Software team.
My name is Naveen Rastogi. I'm the Chief Architect for the data management team.
Okay, and we focus on emerging products in the data protection division. And so we're just going to kind of take you through what we've been working on over the past 18 months or so, 2 years, and talk through some of the new stuff that we have coming down the pike. This is sort of the structure that I have for my talk today. I'm going to talk just a little bit about the problem space that we're focused on with the software that we're building. Take you through that software, what it is, how it works. Going to go as deep into the weeds as we can with you guys today. And then I've got just a quick little 5-minute demo on the back end if we've got time to actually show you the product in action. Okay? So I was kind of chuckling in the back about and during Mark's presentation about the sort of the banter, we'll say, about the DBA versus the backup team kind of dynamic that I think we're all kind of well aware of. So when you take that sort of dynamic and add in the fact of data growth, you end up with sort of an interesting situation here, right? We've got database protection happening by DBAs, typically native dumps to disk, and you have infrastructure protection happening out of backup teams, protecting VMs, storage, hosts, all the rest, right? Add that in with this tidal wave of data, and what we have is a situation where we're protecting we're trying to accommodate these huge volumes of data, and we're trying to accommodate it with a very sort of siloed, piecemeal approach to protecting those databases. And it's a problem because it's expensive, because a lot of times those dumps go to disk, those DBA's dumps go to disk. It's risky because we have a hard time really knowing whether all of our most important data is protected, and it slows us down because you always need both, right? And in order to get both, when both teams are running different tools, there's a lot of tickets, a lot of meetings, that kind of stuff, right? So this is sort of the problem space that we're trying to play in here, and to come up with an interesting solution for customers to kind of unify database protection under one umbrella, right? And I've been working on backup software for many years, and we've tried to coax the DBAs over into the networkers, the Avamars, the net backups, right?
Never gonna happen.
So that is our assertion that going forward, that's just not going to happen, right? So we say, okay, we've built a bunch of great features, networker, net backup. They're actually pretty good at backing up Oracle, right? But that doesn't mean they get used. So we take a step back and think this through, like, how can we put a solution forward, taking that as a fact that DBAs are not coming to the backup app to do their backups? How can we put a solution forward that kind of solves this problem of, again, protecting our most important stuff with this piecemeal siloed approach, right? And our hypothesis is that the way that we're trying to solve this problem is to really kind of build out a new management harness that allows the backup team to kind of transition to more of a service provider model, where instead of kind of sitting in the basement and soup to nuts configuring backups from client down to target, they're sort of providing those protection storage services out to their DBAs. They're providing compliance and oversight services out to those DBAs, and trying to just act in that way where we assume that DBAs are doing their own thing, and we want to kind of establish guardrails around that and make it easy, right? That's the first piece. And then the second piece is, and Mark talked about this a bunch in his talk, we want to make sure that anything we're building new in 2017, 2018, and beyond, it's got to be on a platform that's going to scale with that tidal wave of data growth that is coming at us, right? So that's kind of our hypothesis and how we're kind of proceeding to kind of build out a new solution within DPD. As we kind of go a level down, there are really 3 ingredients that we see as very important to that new solution. The first is sort of a self-service first approach. And we've learned this, as we've spec'd and designed product to go try and serve this need, is when you take that self-service first design center, you make a bunch of decisions that you wouldn't make if you were really designing for, again, that central backup admin sitting in the basement running soup to nuts backups. So we assume always that app admins are going to live in their native UIs and nowhere else. They're never coming to our UI. We want to get them the technology that we've got in the backup software that Mark talked about with the efficient data paths that we've developed over the years. And as we formally turn over the keys of the kingdom to actually running backup and restore, we want to make sure that they're running within guardrails, right? That's one of the hardest pieces of driving self-service operations, is to make sure that you don't drive yourself off a cliff, turning over control to your users. The second piece is around...
Users get a backup license.
What's that?
It's too bad we can't make users get a backup license.
And their own data domains.
You're not responsible for your backups till you've had 200 hours of driving the backup application.
An annual background check. So the next piece is around the data paths themselves. So this is really where EMC, has been very good over the years. We're good at coming up with new and interesting ways to move and store data, obviously. Our approach here is, we're looking for new data paths. We're investing in new data paths, and we want those to be kind of lightweight data movers that we can go embed down into the infrastructure so that we get close proximity to data. And as Mark mentioned a few times in his presentation, always a direct data path down to the data domain. That's sort of religion for us. We've seen such great success with that in the field. Last piece, automate like crazy. Building new product for 2017, 2018, we need to be able to automate off the shelf in a much more effective way than just providing a robust CLI, right? So doing things like discovery and classification as new assets come online, easy provisioning and configuration up and down the stack, and also, preserving that capability for the backup team to come in and tack on infrastructure protection with crash consistent VMs or snaps or whatever, and to have that in that same view is sort of, we also see in that automation bucket. Okay, so I have one more sort of architecture-y thing. Thank you for tolerating the high level stuff. This Mark kind of went through this, so I'll kind of blow through it. But the point I wanted to make with this slide is kind of show you what we're trying to pull together into this new offering, right? So Mark talked about the 3 data paths that we're focused on, being able to go direct from the application, right, with DD Boost. It's actually just a simple set of libraries in the RMAN case. It's not an agent. Hypervisor direct, it's based on our recover point for VM technology, be able to drive that data path direct from the hypervisor. As you move down the stack, you start to get better and better performance the lower you go, both because of your proximity to the data, as well as some of the techniques that we're using to actually locate and move data down to the data domain. And then we have the storage direct path that's just storage to storage, primary to protection over fiber channel, which is very, very quick in order to move that data. One thing that I would point out when we're talking sort of hype direct and storage direct is the backup formats. You got to be a real backup nerd to get excited about backup formats, and I am, right? So at the hypervisor, we're capturing these backups and we're dropping them down as VM images, right, on the data domain, full VM images. And since everything is driven by the DBA, they're app consistent VM images. So that's a super kind of, I think, one of the coolest parts of the solution. And Storage Direct, same sort of situation, except with LUNs, right? So you can get sort of an application consistent set of LUNs on the back end in terms of your backup format. Okay, so that's kind of the data mover picture. Again, it always starts with the DBA, right? Being able to roll this stuff into their native UI. Obviously, they don't know about hypervisors. They don't really often know or understand about LUNs. We try and make that as opaque to them, but in terms of initiating backups, initiating recoveries, simple out of the UIs that they know and love. Now, if you're only protecting one database in your environment, I could kind of stop my presentation here, right? That's obviously never the case. And so, typically when we come in and talk to enterprise users about this sort of setup, that's great, but what about, my 10, 100, 200 databases or more? How are you going to manage that, right? And so it's a module called eCDM that we've been working on to sort of provide that management harness, and with a set of tools that we hope will help backup teams to kind of make that transition from centralized backup software operators to more service providers in their shops. right? And fundamentally what that tool set does is it discovers assets. It has provisioning and configuration automation in it so that it can, create objects on the data domains, set up the data paths, that sort of stuff. It catalogs the backups. So while we have independent sort of backup scheduling happening out of the DBAs, we're still preserving a centralized catalog, and we'll talk about how that works. And then we go out with this tool and enforce SLOs as well. So give users the ability to set their RPO, set the retention windows, set min, max copy objectives, and we'll go out and monitor that based on the metadata we see and attempt to enforce.
Paul, are we going to go down and talk about what platforms you support in a bit more detail? Because you showed some examples there. Can you do, for instance, eventually consistent databases, that sort of thing?
Such as
MongoDB.
We don't do Mongo today. So we have a Hadoop, a module for Hadoop that we do. We're looking at Mongo, Cassandra.
For HDFS, right?
Yes. But we don't have eventually consistent as Mongo today.
Okay.
Just very curious on the asset discovery side of things.
Yeah.
What kind of mechanisms are we talking here? We're talking automated auditing of virtual platforms, looking at vCenter, looking for new VMs, or am I actually tying into a CMDB?
Yeah.
Yeah, so we have a construct in the product that we call inventory sources. And so these are sort of the management servers that live out in the environment that have kind of information about their silo, right? So for VMware, it's a vCenter. So we plug in a vCenter, and that allows us to discover VMs as they come online. For VMAX environment, we use an SMIS server in order to find the arrays and all the storage groups and stuff in the arrays. So every sort of silo has got one of those, and those are what we hit to run discovery
And the idea is
find
that
stuff.
at the discovery stage, it's flagging to the administrator, look at all these new things that I'm not protecting?
Correct. Either that or a set of rules that can go, once I see something new, I can go drop it into policies. Now, it's very common for backup software to do that in a VMware environment, right? That's something that everybody does. But we kind of extended that out to database environments, to storage environments. So it's sort of any object that we discover, we can then go classify and shuttle off into a group
backup
that has SLOs. Yeah.
Okay.
Any other questions? Great stuff. All right. So what I'm going to do now is 1, 2, 3, 4 pieces. I have four slides. I'm going to take you through each one of these in depth and.
Hold on.
Sure.
So everything I'm seeing here is about managing backups, correct? Not restore workflows. I don't see anything about restore workflows because we're talking about a moving target now. It's not what it used to be, where you just back up a database, restore a database. They want these database copies restored in different ways. They need to restore them into different environments that may be compliant, not regulated. They need data masking in the restores. What are you guys doing on that front?
So that's why backup format matters so much, right? Because if I'm running backups as tarballs, which is traditionally what we've done effectively, right? Streaming backups are effectively tarballs for the most part. It's really hard to do anything with them other than kind of unpack them and send them back to where they came from or to some other host, right? And this is really sort of, and what you're talking about here is really driven the design decisions to land backups in usable native formats, right? So we still have work to do up at the application side, but as we go down the stack, when you land a Hypervisor direct backup, you have powered off VMs sitting there on the data domain that you can boot up at any time and start and go access, right? Same with these LUNs, the backups for storage direct land sort of as LUNs on the data domain in sort of what we call a vDisk pool. And those you can mask out, mount up on a host and use. And then the overarching management framework has a robust set of APIs to go manage that if you want to do something interesting with those.
Is there a workflow engine in that?
There is a native workflow engine in the product, but in terms of, it doesn't go as far as I think as you're asking me about in terms of adding on like masking or any other.
Yeah, because ultimately, I mean, backup is great, but it's really and I'm again, these enterprises that I've been talking to, the big ones are starting to realize that things got so big, and they've really architected their environments, and many of them have data domains, and the backup environments, they've optimized to get their backup windows done. And then when something bad happens and they have to restore a database of any size, all of a sudden they realize, oops, I've architected for the wrong thing. I've architected for my backup, and I should have been architecting for my restore, because that's why we do this. And you know, at least for availability restores, right?
That's always fun when they try and do like Veeam instant restore from a deduplicated data.
Yeah, it's hilarious. Yeah, I mean, the thing is, it's all great until you actually have to use it. It's like an EDR product, right? I mean, but I mean, I've talked to probably 5 different, I mean, large enterprises, guys you do business with, guys that, you know, IBM does business with, that net backup shops, you know, they got a lot of different things running around. And they've really architected very well for getting that backup done fast. And they've bought into this philosophy in general of working to that way. But then when the business requires that data to come back, they're not meeting any, the SLOs shouldn't be for the backup, they should be for the restore. And that drives the architecture for the backup. So I'm trying to figure out where you guys are approaching this from a logical angle.
I think I can just add a few things in here, right? So one of the questions that you asked about, you know, data masking and other things, I think right now from EMC perspective or Dell EMC perspective, we are not playing into that one, because this very specialized niche thing, right? How do you protect
Others in
the
your space are doing it.
Right. So yeah, so I think we're working with, you know, looking at, you know, how do you partner, because it's a totally different things. But when you say restore, right? Restore, as Paul has mentioned, native format. Native format is very important. So even for LUN's perspective, I can do instant access on that one, right? Whether it's a VMAX, whether it's Extreme IO, I can make the copy that is made available on data domain, make it exposed to a recovery host, and the host can start accessing it, bring up the application. So you don't really have to move the 30 terabytes data first, and then start your application.
I could do that for DevOps, for development copies and test and QA as well.
Right. So that's there.
That's really the workflow that I'm talking about.
So that's there, right? So that's also built into the ECDM. So we have defined at this, and Paul go through that scenario for both for VM, both for LUNs, because the image has to be in native format so that it can be made available without actually streaming back all to recovery host and bringing it up. So that's all there. And in addition, things that we do within VMAX, within the VMware, is differential restore. Let's say you said something got corrupted, right? You had made a backup yesterday and something got bad, and then you want to do full rollback. So instead of rolling back all the 20 terabytes, we have the technology between the VMAX and data domain that we look at, hey, what's the difference? What was the last thing? And we just feed only the bits which were changed between that time and then restore to the production. So your production, instead of moving all 10 terabytes, 20 terabytes, you probably move only 1 terabyte and then bring it up. So that's all built in there for some of those functionalities.
Right. I mean, and there are workflows already provided to do that.
Right.
That's what I'm asking.
Yeah.
It's I understand technology is there to do
Yes,
that.
yeah.
You guys have the technology to do everything.
Yes.
I get that. I mean, that's a good thing. But ultimately, especially if we're going to let DBAs do their own stuff, we have to make it transparent. They can't know about what's going on in the back end. They just have to ask for this, and this, and you know, how the sausage gets made, they can't be aware of. That's the whole point, right?
Yeah, so from a DBA perspective, they just run the command like, okay, from in RMAN, I'm running is rollback database XYZ. Within the rollback command, when it comes into the plugin part, plugin makes sure that, hey, can I just take the full VM image, you know, assuming it's running on the VMDK, can I just take that VMDK and do a restore internally without interfering with my database or DBA workflow perspective? Internally, it makes a logic, yes, if it is, I can just do the full VMDK restore, or I need to do a granular restore on that part. So that's all built into the plugins.
Yeah, I mean, most of the enterprises now are really, it's also the workflows are not just for the DBA, but they're also for the devs who need DBA copies for this stuff, you know, of production data in their, you know, in their development environments, and sometimes you could have multiple copies of that stuff. So this is so far, I see those 3 things are for data domain, and you said you were also working on snapshots. On the same product is going to manage snapshots as well on production, VMAX,
Yes, we support snapshots on VMAX and Extreme IO today. So those are the platforms that we're focused on. And when we go out and discover against an SMIS server and discover that VMAX environment, we'll pull back all the storage groups, right, and make those visible to the user in the management framework. But we'll also pull back all of the snapshots that have been taken, even if they weren't by us, right? So if storage admins are out there running snapshots, have external tools that are, running snapshots on the schedule. We'll bring those back and show them to you and allow you to recover from them as well. So we can drive them or discover them.
So the ECDM product is its own thing. It's going to be grabbing a lot of metadata from all your different points, your vCenter, the database and stuff like that. You're aggregating them. I'm sure there's a central server. What's the back end look like on this thing? Is it a transactional database? What kind and all that kind of stuff?
I'll go for it.
Yeah.
Just.
So the ECDM is a virtual appliance, right? A virtual appliance, and it has, I don't know if you had, yeah. So it has right now, and all this catalog is Elasticsearch, which we are leveraging in that one for all the catalog, everything that lives around, whether it's the VMs, whether it's copies, and everything else is all stored in the Elasticsearch. And I think these, as Paul has shown it here, right? So there are different components. I think there was a question that you asked about the workflow. So we have a workflow engine, but at least to say, can user do the workflows from making, DBA, test and dev copy? Those workflows are built in there. I can restore to alternate, right? Whether it's a VM or I can bring it to a recovery host from a Lens perspective. So there are different components of the ECDM.
Yep. So it's lightweight OVA. It's cool. It's fun to be able to work on a new product for 2017, 2018. Kind of go with that services-based approach. A bunch of little services connected via REST on the back end. A bunch of them also stood up on open source. And then the UI itself is everything that you expect from a UI in 2017, right?
And the REST APIs.
RBAC driven, based on public REST APIs, Angular, Node, all that good stuff.
Now, is this like the other OVA that we get free if we're already a licensed client, or this is a new paid-for product?
So for the most part, anyone who buys our software is buying in suites, right? And so this comes in the suite, the data protection suite for applications and the data protection suite for enterprise. So it's in 2 of our 3 suites today. So, which covers a big range of our install base. Okay. So let me pop back to here real quick. And again, what we're going to do now is just one slide on each of these 4 pieces, right? So application direct, I think we've talked about it enough today. It's, quick and dirty client-side dedupe plugged into the native UI of the DBA, right? So with that process of identifying segments, checking whether they're unique on the data domain, and if they are unique, compressing them and sending them down to the data domain. We call that distributed segment processing as a fundamental characteristic of this data path. It supports link failover and load balancing on the data domain with data domain if groups. We support for fiber channel if that's what the customer wants to do, to conduct this process over fiber channel. We also make failover transparent to the DBA. So if I'm sitting there in SQL Studio and my primary data domain fails, Boost is smart enough to go to its replica for recovery. And again, all driven from the DBA's native UI. So way to think about this is just a quick and dirty client-side dedupe stream out of SQL Studio, right? And this is widely deployed today in especially SQL and RMAN environments out there in the field today. So the second one is that Hypervisor direct path. Now this is brand new. It's only a few weeks old. Just came out in Q3, late September. So I'm going to walk you through kind of how it works and what it's actually doing to kind of achieve that higher level of performance, right? So in order to get it working, we install a splitter on ESX. We also put down a virtual recovery point appliance. Those are sort of the 2 pieces that ECDM is going to go out and provision and set up as a part of its normal kind of provisioning automation job, right? So once you've got that in place, how it works is that the I/O to disk on ESX is split, right? And the RPA cluster starts to track changes on a per VM basis, and that's really important. We're tracking those changes on a per VM basis. Differences for each VM are shoved into what we call a differencing disk that is sitting there on exposed to ESX or on ESX. And at backup time, what we do is we snap that diff disk and transmit it down to data domain via Boost. Okay. Then on the data domain, we synthesize. So now we've just sent our differences down since the last backup time, and we when we land those in the data domain using DDFS and sort of the pointer-based nature of that file system, we synthesize a full on the data domain, right? And so you end up with sort of generations of virtual machines sitting there on the data domain that you can go recover and or use.
Well, where's the splitter sitting?
On ESX.
Exactly what in the kernel?
Is it a
in a
virtual
VM?
machine? Is it a
Or
kernel module?
It's a kernel module.
right, so that's a bit of an installation process
And
to
that's
get that
correct.
working. And how do you monitor the overhead and the impact of how much that's taking in terms of process time on the?
So
on the
from a
platform?
CPU cycle, there are a few CPU cycles that are definitely used, right? So so it's a fixed kind of, from memory perspective, it's kind of fixed and reserved.
But wouldn't it be variable depending on the activity of the VMs?
That is correct, right? I'm saying it's basically based on what's I/O is happening, right? So it is not keeping everything in memory. It is just says, yes, I/O comes in. What it does here is, right, when you write in here, so I/O comes in to the splitter would send it to the production, and it'll send it. So till the time the I/O is acknowledged by both the sides, it's there. After that one, it's just say, no, yes, I'll get it, I'll forget it. Just like a network switch.
Right, so this-
Packet comes in, and then you forget after
Yeah,
that.
but
You don't need to worry.
there's a bit of design work to make sure you get that right, because if you're not writing the diff copy as
Yes,
quickly as
but-
you're writing the production copy, then you're potentially
Yeah, so that is correct. So I
running
think actually the memory impact is not on the splitter, but on the VRPA, because as soon as it gets into the virtual appliance here in memory,
yeah.
it's committed, and then a response is sent.
And do you get to see that? So can you look at that and scale it and say it's managing to cope with the size of the environment, or it's not managing to cope
So
with it?
virtual this cluster, VRPA cluster, so they come in different sizes, in different scales. You know, how many IOPS it can handle, how much memory is requirement on that one. So there are different scales on that one depending upon the sizing. We deploy a different.
But I can't monitor it. I can't see how busy it is or whether it's likely to have an impact.
Today in ECDM, we see the overall health of that one.
Right, okay.
Right, but we don't dip deep down into that one, how much CPU, how much memory it is there in today's world.
Okay.
Yeah.
On that, 2 questions quickly. Backwards compatibility, how far back can I go on ESX?
5,
5050?
5 onwards.
55 onwards, okay. That should be fine.
Got to be supported.
Back to whatever's supported.
Yeah.
And then the other question is, how do we handle things like identifying when I'm moving vMotion, for example? I've got a splitter on an ESX, and I've just moved this machine to another host, who is now splitting I/O to a local appliance.
Yes. So I think what happens, I think from you're talking about
vMotion is a first example. Start vMotion would be
right.
worse, but
So vMotion is, so the way the splitter would work, so what we make sure that within the vCenter, the splitter is assigned to each of the ESX on that one. And there are APIs in the vCenter that, hey, if new ESX blades are added into the vCenter, then we get notified, and then we also push that splitter onto that one.
Okay.
So that means splitter is always available whether it's in use or not. If it is not used, it's not doing anything, it's a kernel module just sitting there and doing nothing in that time.
okay, no, the question is more on the point of view that the splitter is sending it to a VM instance on an ESX, which is attached to differencing disks.
That is correct.
Now, those differencing disks are attached to the virtual machine on an ESX host. When I vMotion, that differencing disk associated with that virtual machine is going to be attached to a...
No, so differencing disk is attached only to the VRPA. It's not attached to the,
No, but
so
that's-
and this one does not move. Sorry.
But that's the problem. I'm sending differencing flows to one machine, and then I move the virtual machine that I'm protecting, so his flow, the splitter, is going to be going to another appliance. How do you marry those two back together to know the differencing disk belonging to virtual appliance A is now receiving writes from a machine that was protected by B 2 minutes ago?
So no, so splitter is independent. Splitter part of the configuration from that perspective is that lives within the VM
host, yep.
environment. So splitter is kind of independent. Splitter it is just working as a data mover for that one. So your question is, if I move that VM from ESX A to ESX B,
Yep.
am I sending which splitter I'm using? First of all, splitter B would be used, but there's a mapping, internal mapping, which is maintained that, hey, even though I'm using splitter B, but it still needs to send to the VRPA cluster, IOs for that one.
Okay, so in fact, it's actually a fully clustered environment between all of the VRP So they know about the location of all the virtual machines, and they know about all the differencing disks that are protected.
How is this different than recovery point for VM?
So it is using
So does it meet
VM
the same
internally.
infrastructure requirements like iSCSI?
Right. Yes. So
Okay.
iSCSI is used for actually differencing disk for that perspective.
Okay.
And recover point for VM, I think in 5.1, which was announced at the VM World. So there are two workflows, which is the CDP, which is the continuous, and what's called the SPR, the snap-based replication. So it's leveraging the snap-based replication technology for that.
Okay.
Any other questions on Hypervisor Direct, sort of how it works?
So does the VRPA require separate administration from the other stuff? I mean, are we administering recover point in that case?
No, our goal is entirely to have all of the administration happen through ECDM, right? So ECDM takes charge of getting those RPAs deployed. It shoots, RP for VM licensing in the head when it gets, when it's deployed in this personality. It, instructs it to deploy the splitters. So all of this is happening from.
But
from
I guess my
ECDM.
point is this: if I'm running into any problems, right, and I'm calling support, I'm dealing with the recover point group for Hypervisor Direct. For application, I'm dealing with data domain support because there's no RPA with that version. I think, right? I'm just making sure. There's no recover point on the application direct one, right?
Right.
That's
That's
something.
just Boost.
That's just Boost. That's the data management group alone. This has the recover point and the data domain group, and then I guess we haven't got to the next one. Is not going to have recover point either. I guess.
Yeah. So
It's just trying to.
from a support
Yeah.
perspective, you're going to call and file an SR against
ECDM. I get that.
Period.
Okay.
Now, does that say that we're perfect and we don't have improvement to do on making sure that you have the quickest route to the the technical expert? I mean, that's work that we're doing sort of on the back end to kind of bring all this stuff together, right? But you'll call on ECDM. Okay, so just from what this gets you, what this approach gets you, since we're tracking the changes consistently, we're never quiescing VMs. This is a great fit for high change rate VMs. This is really where the solution shines. That's just a poor fit for VADP. We do DSP for transmitting the data down to data domain, and we multi-stream on the fly, right? So these are sort of all the cards that line up to try and get us that performance that we expect out of this solution. In terms of benefits, there's no VADP in the picture at all. So there's no snap and merge at all in the process, and that alleviates stun significantly, right? You get high performance, and then again, those DBA-driven backups are landing as app-consistent VMs at the end of the process, which I've already expressed.
So which hypervisors does this solution support?
VMware.
Just VMware?
Yes.
No Hyper-V?
No Hyper-V today.
Is it on the roadmap?
We're working on that. Yeah,
KVM 2? Maybe?
maybe.
Those are the three we see.
Yeah. Okay. Any more questions on Hype Direct before I move? Okay, Storage Direct. We're calling it Storage Direct now. If you're familiar with the Protect Point's an older term for the same stuff, so if you've seen Protect Point, then you can just kind of change the term in your mind. How this works, and this is the VMAX example. The XtremeIO example is a little bit different. There actually is a recover point appliance in the flow for XtremeIO. Kind of looks a little more similar to Hype Direct actually, but for VMAX, what we're doing is we have a construct on the data domain that we call a VDisk. We take that VDisk and then go encapsulate it onto the data domain, set it as a snapshot target. Use SnapVX on the VMAX side to sort of efficiently create a set of differences, and then we tier those differences down to the VDisk using FastX, right? So it's a very efficient way to sort of find the changes and get them tiered down to the VDisk, and that process transmits those changes, unique blocks coming from that SnapVX snapshot over Fiber Channel to the data domain, and then again, we go synthesize on the data domain to construct what looks like we call them static images. It looks like that full set of LUNs that you snapped at the top of the process, right? So it's sort of efficiency with the SnapVX, efficient data movement using using the data domain sort of efficiency all the way down, draining out over fiber channel, and it's just a very, very, very fast way to move data storage to storage, right? So I kind of, in an elevator pitch, whenever I talk about this, I kind of talk about it as change block tracking for arrays, change block tracking for primary storage. We also have change block restore here, which Naveen talked about on the a bit earlier, and can export off of the data domain here. So that is storage direct. So those are our 3 data paths that we're focused on. Each one of them is very different, right? And that's really what our challenge is how do you put a user in a position to be able to manage and operate 3 data paths that get you a ton of benefit, that are very interesting but very different, right? And so this is where the ECDM piece comes in to try and simplify that and make it easy enough for a DBA to leverage any of those 3 paths.
I think to be clear, it's I mean, and I apologize in advance for saying this, but it seems like it's a great way for DBAs to consume data domain. That's what it's for, right? So, I mean, if that's the goal, that's great. But it seems like ECDM is just a product to basically get things on the data domain, and that's like the answer for everything. And I mean, I like data domain, especially with the virtual idea, is going to be great. I'm sure that that can be the virtual data domain, not just a physical one, right? It'll totally apply, right?
Correct.
Yeah,
this has fiber channel requirements, right? So you're getting for DDVE, right? Because this is over fiber channel, right? The other 2 at the VM, at the hypervisor level, or at the application level, those are going over network.
So I can't do to a virtual because I can't expose fiber channel. Is that what you're saying for storage direct?
That is correct, right.
Oh. Okay. So I have to have the appliance. All right.
And this is only Vmax.
Vmax and Extreme IO.
Yeah. Are you planning to extend that to mid-range?
Well, see?
We're looking at it right now. Really, the benefit though is for those huge databases, right? And so the workload fit. It's not something we have planned that we're actively working on right now. We're going to continue to look at it. I think at some point in the future, it's going to be a definite requirement. But right now, it's sort of focused on
mid-range is getting up there in capacity.
Correct.
So
Correct.
They're starting to feel the very same pain points that we see historically on the big iron.
Sure. So I think we'll get there eventually, but right now it's really for those tens of terabytes types of databases where it really shines. Okay, so we'll talk a little bit about management, unless there are more questions. So we went through this slide already, sort of what is the kit, what physically is ECDM. Instead of trying to bombard you with feature bullets, I figured in order to kind of explain how the product works, I just kind of take you through a bit of a day in the life type of workflow example. So we're going to just take the simplest one, which is going from discover to protect for boost, protecting SQL instances. Okay, so we're starting with that sort of application direct flow, boost for SQL. Again, just fast, lightweight, DBA in control. The first thing that we're going to go do is discover the databases on that host. Since we're so focused on the DBA, so focused on the databases, one sort of difference that we're trying to implement here is that we protect databases, right? Not database hosts, not application hosts, right? So we go discover the databases on a server. That process gets triggered by a boost install. Right, so whatever package management system you have out there to put software in place, that would trigger this discovery process. So we go out, find the databases that are on the application server, and establish a communication link back to ECDM. Once we have that, we're going to go do some provisioning and configuration. So in the spirit of kind of maintaining a single UI API for a backup team that is looking to deliver this sort of services to their DBAs, we provide in the ECDM UI the ability to go cut up your data domain, create M trees, replicate them, assign quotas, stream limits, all that stuff, right? So all that provisioning stuff is there, and you can hand that out to groups of databases. We're also going to go set up do any setup that is required on the RPAs, for example, creating consistency groups, stuff like that to get them ready for backup. So we'll do that provisioning as a response to freshly discovered assets. And we're going to ship out to the DBA's native UI, in this case, in the SQL example, out to SQL Studio, all of the target and credential information that they need to just hit that backup now button, right? So steps 1 to 3 here are all about from the point where our bits show up, right? A DBA says, yes, I want to install a library here to back up to data domain. That should trigger automation all the way down to the start backup now button. And the goal here, the bar that we're really trying to meet, is no meetings, no trouble tickets, none of that. That should automate all the way through to the point where I can start running a backup, right? The backup team should not have to know that new databases are coming in online in order for the DBA to go start running backups, okay? So we assume now that the DBA is running backups, and ECDM is following along and cataloging those backups as they happen, right? The way that we do this is we basically leave breadcrumbs on the client up to a limit, and we have an ECDM agent written in Golang that sits there and kind of sweeps those up and sends them home to ECDM to go into the catalog. Now, this is different than sort of the traditional kind of central command approach for driving backups. And it's pretty cool because it breaks the dependency between the server and actually running backup and recovery, right? So in this case where you've got, SQL backups, running 1,000 a day, right? Logs every 15 minutes, you can go upgrade the ECDM server without actually interrupting backups occurring on the from the application host. And that's a big driver for folks sticking with just native tools, for the DBAs sticking with native tools, because they really don't want a backup server as a dependency for their log backups, right? Too scary, okay? So that's the fourth step, is sort of that ongoing metadata collection process, right? We're discovering, same thing would apply for snaps on a Vmax array, for example. And then we go, once we have that metadata, we go run protection compliance against it, right? So we allow you to set up SLOs within ECDM. What's your RPO? What's your retention? What are your retention needs? And then as we gather that metadata in from what is actually happening across all of these application server endpoints, we go through what we call a compliance run and evaluate the degree to which you are making or not making the SLOs that have been specified. Some of those SLOs can take on an active personality as well. So for example, on the retention side, it's not just are you making your retention window or not. We can actually go in there and apply locks on the data domain and say you will make your retention window because I'm going to make these backups not deletable for 30 days, right? We also have the inverse, or the opposite, where we can go in and say you will not just dump backups to disk forever. We will delete any backup that is 30 days old or older, right? So retention is one of those areas where big lawsuits can occur, right? Companies can get into big trouble by violating retention rules. So we kept the ability to keep that centrally. And then the last piece is sort of if you want to layer on crash consistent protection, if you want to layer on snaps, if you want to layer on crash consistent image backups, ECDM does have an internal scheduler, and so we can go drive that crash consistent backstop as well. So,
Paul, I'll add one more thing on the bullet 3 where you had actually bullet 2, the third row, communication link. So there is not every database, if you want to discover, if you want to control which one. So there's a whitelist functionality available that you can say, hey, I want databases on running in this subnet or these IP addresses only to be auto-discovered, not everything else in that one.
Don't pick up test and dev by accident.
That is correct. So there's a whitelist functionality in there.